Hi, I'm George Self. This video is one in a series designed to help with the R labs for BASV316 Introductory Methods of Analysis. This is lab number 3, Dispersion. Dispersion is simply a measure of how scattered out the data are. It's dispersion. How wide is the data set? There are several measures of dispersion with R, and they're all fairly easy to calculate. The first measure of dispersion is simply the range. That is, what's the difference between the lowest value and the highest value in a vector? For our demonstration, I actually have 5 different ranges that I'm calculating. A single line here is all you need to calculate the range. I'm doing it 5 times just for fun. If I run this, I can see that, for instance, the range of the area of the rock data frame is from 1016 to 12,212. Well, this is an easy enough command. Let me copy this and scroll down for the guided practice. I need the range, and I'll paste that in. I need the range for the faithful data frame and the eruptions. If I run this, I see that the eruptions, and that's how long the eruption lasts in minutes for the Old Faithful geyser in Yellowstone. And the shortest eruption was 1 minute and 6/10, and the longest eruption was 5 minutes and 1/10. The deliverable for range is in the cafe data frame. Let me paste this in. In the cafe data frame, I want the range for age. And I run that. And I see that the youngest customer in our cafe was 20 years old, and the oldest customer was 70. So that's range. Next are quartiles. Again, these are measures of dispersion, how scattered out the data are. Quartiles would be dividing the entire vector into 4 parts. The lowest quarter, the second quarter, the third quarter, and the upper quarter. And R makes it pretty easy to do that. I will point out that I have, again, 7 different quartiles or different quartile demonstrations here. If I run this, I'm using the summary command, and I'll let that run. For rock dollar perm, the permeability of a rock sample, you can see the minimum value is 6.3. The first quartile is 76.45. The median is the same as the second quartile, 130.50. Then you can see the mean. The third quartile is 777.50, and then the max value. So to find the quartiles, we use this summary command. You get a lot more data out of there than just the quartiles, but quartiles are all we're interested in for this particular exercise. So I'm going to do summary of U.S. judge ratings, and those capital letters are important, and WRIT. These are the judges' ratings, lawyers rating the judges that they appear before, and this is their written opinion values. I can run this. You can see the first quartile is 6.9, and the third quartile is 8.05. And this is on a 10-point scale. For the activity, I'm going to take again this same command and copy it. I will paste it in here. we need the quartiles in the cafe data frame for age. And the instructions are to record the values for the first and third quartiles. So it would be the first quartile 35.00 and the third quartile is 51.00. Now if you have quartiles, then you can actually calculate the range between those quartiles, the difference between the third and the first quartile. And the function to do that in R is IQR, interquartile range. And I will point out this is one of the few R commands that are in capital letters instead of lowercase. For the demonstration, I have 7 different IQRs that I'm calculating here, and I'll run this. And you can see the interquartile range, for instance, for rock $perm is 701.05. So the difference between the first and third quartile is a little over 701. Our guided practice, well, let me copy this because that's what I always do. And I will paste it in here. I need the interquartile range for, oops, I better scroll up here 1 dot. In the Swiss data frame, the IQR for agriculture. And again, the capital letter there is important. And you see the IQR is 31.75. And the activity for this lab, I'm going to copy this. And I will paste it in here. The activity is the interquartile range in the cafe data frame for age. And the interquartile range there is 16. Standard deviation, now that's one of those terms that a lot of students get confused by, and I'm not sure why. It's a fairly simple thing to understand. A standard deviation is a measure of dispersion, that is how scattered out the data are. And you'll notice here that I've got some graphs. I explained standard deviation for this particular video. I'm not going to go through all of the explanation. Let's just jump into how R calculates standard deviation. And you'll see the command here for R is pretty complicated. SD for standard deviation. I have 7 examples that I'm going to run for the demonstration. And the standard deviation for rock $perm is 437.8182. The guided practice for standard deviation, I'm going to change just a little bit. Instead of copy and paste like I always do, I'll just type this in. Standard deviation for stack loss $air.flow. And run this, and that standard deviation is 9.16, 9.17 if it's rounded properly, and we want to round properly. The activity that we're going to submit is a standard deviation in the cafe data frame for age, and that standard deviation is 10.73. Again, you're welcome to round to the second decimal place. That would be fine. That's about it for this lab. Good luck with your lab. As always, please do not get frustrated. If things get a little frustrating for you, stop, contact me, and I'll be glad to help. I'll be seeing you online.